All right, so we have the natural log, or not the natural log, the common log of this stuff here, x minus 3 plus the log of x is equal to 1. I can't stress this enough. If you see the log of something and they don't list a base, that it's implied that that's the log base 10 of m. All right. This is called the common log. It's just we have a decimal system, and our number system is base 10, so mathematicians don't write down the 10. That's all. So if you don't see a base here, it's 10. That might be helpful later on. But anyways, let's go through this. Using the properties of log, because I'm adding two logs with the same base, I can make them a product. In other words, this changes to the log base 10 of x minus 3 times x, and that's equal to 1. In the next step, what I'm going to do is I'm going to distribute that through the parentheses, and I get the log base x squared, base 10 of x squared minus 3x is equal to 1. All right, so now I've got to solve this. So to solve this, I can use that property. Remember that b to the n is equal to m, and that is the same as the log base b of m is equal to n. So my base is 10, right? So I'm going to say 10 raised to the n, which is 1, is equal to x squared minus 3. X. And I'm just double checking and making sure, yep, because the base is 10 of m, this is m, yep. So then I got 10 is equal to x squared, because 10 to the first power is just 10, equal to 3x. Now to solve this, I'm just going to subtract 10. Remember, for quadratics, we want to make a quadratic look like this: ax squared plus bx plus c equals 0. And then we factor it to make it look like x plus p times x plus q, and make that equal 0, and that gives us x equals negative p and x equals negative q, if we can do that, okay? So I subtract 10 from both sides. I get 0 is equal to x squared minus 3x minus 10. So to factor that bad boy, I'm going to, over here, we're going to use the guess and check method. I'm just going to take the first term and the last term. So the first term is x squared. The last term is negative 10. X times x is x squared. Now to get negative 10, I'm going to do 2 times 5. But remember, this middle term is the sum of this term and this term. In other words, in order for me to get my negative 10, either the 5 or the 2 has to be negative. I'm going to make it the 5, because when I multiply negative 5 times x, I get negative 5x. And when I multiply 2 times x, I'm going to get a positive 2x. And guess what? Those add up to negative 3. In other words, this is equal to x plus 2 times the quantity x plus, not plus, minus 5. So in the next line, in order to get 0, both things in the parentheses has to equal 0, right? So, oops, I'm getting ahead of myself. So to solve this, I'm going to say x plus 2 equals 0, and x minus 5 equals 0. If I subtract 2 on both sides here, I get x equals negative 2. And then if I add 5 to both sides here, I get x equals positive 5. Now, I've got a positive and a negative number for x. When you've done all this work, what you got to do is you got to go back and plug this into the original equation to see if it will work. So let's go back to the original equation. I've got log base x minus 3 plus log of x, that should equal 1. In other words, on my calculator, and I'm going to do 5 first, I'm going to say log in parentheses. Actually, I don't need the parentheses. I'm going to say 5, what was that equation? 5 minus 3 plus log of 5. And let's just hit equals. It does equal 1. So right off the bat, I know that 5 works. So now I'm going to do the same thing. I'm just going to plug this in the calculator and see if it equals 1. So now for the next line, I'm going to say log. The second option was negative 2 minus 3 plus the log of negative 2. Now I already know before I hit enter, I'm going to get an error. The reason I'm going to get an error is because I can't take the log of a negative number. Okay, so let's take a look at this. Got an error. Now here's why. If I go to up here and I graph log of x, watch what happens when I graph this. Notice that it stops right here. It doesn't cross over to a negative number. I'm just going to leave it at that. We'll talk more about that when we do the properties of logs, when we get to graphing logs. We'll talk about the domain and range of logs and where that comes from. But it basically comes from the relationship. And we'll talk about that on another time.